Alright, so we are continuing our work with trig to solve some right triangles. And when I say solve a right triangle, what I mean is we are going to find all of the measures of the sides and the angles. So I need to know all three sides and all three angles. And I also wanted to remind you about some things that we know about right triangles, because we can use all of these tools to help us solve right triangles. So we've got the Pythagorean Theorem. Don't forget about that. Remember, that helps us find any of the sides as long as we know two of them. We've got the special right triangles. Remember the 45, 45, 90 and the 30, 60, 90 that we've already learned about. We've got trig ratios. Remember the SOHCAHTOA. And again, that helps us find sides again. And then we also know that the sum of the two acute angles is 90. So for example, these two acute angles in a 45, 45, those add up to be 90. 45 plus 45 equals 90. Same thing with 30 and 60. Those two add up to be 90. So that will always be true in a right triangle. And so I wanted to introduce one more new thing for us to help us in solving right triangles, and that's inverse trig ratios. So we're going to use these inverse trig ratios to find angle measures. So notice in this triangle, I don't know any of the angle measures, so I can't just do 90 minus an angle to find the other one. So we're going to set up our trig ratio to help us solve for this angle A. So what we're going to do is we're going to notice that the two sides that I have is opposite and adjacent to angle A. Here, let me mark angle A so we can see that more clearly. Here's angle A, and this side 16 is opposite and 20 is adjacent. So that means we're doing TOA, which means we're going to set up a tangent equation. So I'm going to say tangent of angle A is equal to 16 over 20. Now, what a lot of people want to do is they want to say that this is tangent times A. Okay, that's not tangent times A. When we say tangent, we're describing the relationship. So this is really tangent of A. So we really need a completely new kind of math operation in order to deal with canceling out and finding just what A is. So if I want to do the inverse operation of tangents, we have what we call inverse tangent. And it looks like this. It looks like a tangent with a -1 as an exponent. That just means inverse. So the way we say that is inverse tangent. So if I do inverse tangent on both sides of the equation, then what's going to happen is the tangent and the inverse tangent are going to cancel each other out. And that's what we want. We want to get A all by itself. Now over here I have the inverse tangent of this fraction. And all we have to do with that is type that into your calculator. So if you look at your calculators, there should be a button that says inverse tangent. It's usually above the tangent button. So you're just going to type that into your calculator, inverse tangent of 16 over 20, and it gives you 38.7 degrees. Also make sure that your calculator is in degree mode. If you need help with that, I'll help you with that in class. So we've just found that angle A is 38.7 degrees, just by using this new idea of inverse trig. So let's look at another one. Get rid of this. So here we've got another triangle, and I want to find what angle A is. Okay, so I've got this side, which is opposite of A, and I've got this side is the hypotenuse. It's across from the 90-degree angle. So I need to use the trig ratio that has O and H in it. So that's so. So I'm going to use sine. So I'm going to set up my equation. Sine of A is equal to 14 over 26. And then just like tangent, I have an inverse sine. So in order to cancel out the sine on the left-hand side, I'm going to use inverse sine. And it looks like that. So I'm taking inverse sine on both sides of the equation. The inverse sine and the sine, those cancel each other out. And that leaves me with just A on the left-hand side. On the right-hand side, I'm going to type that into my calculator, and it's going to give me 32.6 degrees. So we just found that this angle A is 32.6 degrees. Something else I want you to know is some vocabulary with angles. We're going to encounter in a bunch of word problems these words of angle of elevation and angle of depression. And all that is describing which angle they're talking about in a diagram. So you see this guy over here, and he's waving to his friend up on the cliff. All right, so this angle of elevation, if he looks straight out, just looking straight, normal, not looking up at his friend at all, then he's looking at horizontally. So this red line is the horizontal. But now if he changes his sight, where he's looking from just straight out, and then he's like, oh, hey, there's my friend, he is looking up now. So look at how that red line moves. It's going from straight out to up at his friend. That is called the angle of elevation because he had to elevate his head, tilt his head up to look at his friend. Likewise, his friend was looking straight out. So the friend up here on the cliff, she's looking straight out. And then she saw her friend and she's like, oh, hey, there he is. So then she had to look down. So that's called the angle of depression. All right, so see how that moves, that hinges that angle of depression. So that's all I need you to know, is that that's what those are called. All right, so the other thing I need you to recognize is that these make that Z shape. These are alternate interior angles. And what do we know about alternate interior angles? Yeah, they're equal to each other. So anytime you see an angle of depression, it's going to be the same measure as the angle of elevation. So if this was 20 degrees right here, that was also 20 degrees. So if he has to look up 20 degrees to see his friend, she has to also look 20 degrees down to see him down there. All right, so let's do an example with angle of elevation. We're building a track for a model train, and we want the track to incline, so that we're building like a ramp almost. And it's going to go from the first level to the second level, and that's 4 inches higher than the first level. And we want this to happen in a span of 96 inches. And they want to know, is this angle of elevation less than 3? So here's they're pointing to that. This is the angle of elevation right here. Remember, it's between horizontal and the diagonal. That's how you can identify that. It's not here. Do you see how this angle in the triangle, that's between a vertical line and the diagonal? That is never an angle of depression or elevation. It's always from horizontal and diagonal. So if we want to find that, again, this is using inverse trig. We're going to figure out what sides do we have. We have opposite side from that angle. The 4 is opposite. And then the 96 is adjacent. So that means I'm using TOA. So let's look over here and say, okay, we're going to do opposite and adjacent, which is TOA. So that means tangent of x is equal to 4 divided by 96. And again, to get rid of that tangent, I'm going to do inverse tan. So I'm doing inverse tangent of both sides. And I'm going to type that in my calculator. And that's going to give me 2.39 degrees. So what is my question asking? Is this elevation less than 3 degrees? Yes. 2.39 degrees is less than 3. So we know that it's less than what they were asking us about. This happens a lot when we have ramps or anything. There are a lot of codes on how to build ramps. You don't want something to be too steep for people to walk up, or if you have like a wheelchair ramp, you don't want it to be too steep. Otherwise, the wheels would go too quickly down the ramp. So this is very common for things to move easily across a ramp. So let's go down to this one. We're going to be solving a right triangle. So again, reminder, solving a right triangle means I have to find all of the angles and all of the sides. We are given angle C, that's the right angle, and we're given angle A is 23. So we still have to find angle B, and we have to find these other two sides. We're given the hypotenuse, but we have to find BC and AC. So let's first talk about the angle. All right, I know that from the previous section, we said that the two acute angles in a right triangle add up to be 90. So I know angle A and angle B add up to be 90. Well, we know angle A is 23. So all I have to do is subtract 23 from 90. And I get angle B is equal to 67. So that's pretty simple to do. There wasn't a whole lot of calculation there. So let's move on to BC. All right, so BC, I'm trying to get this. So we're dealing with BC. This is, I'm going to mark this. BC is opposite of angle A. And then I also have this given length of 40, which is the hypotenuse. So that's why I have so written here. We're going to be using sine to help us find BC. So I'm going to set up my equation. Sine of 23 is BC divided by 40. So if I'm trying to solve for BC, I'm going to multiply both sides by 40. So I'm going to do 40 times sine of 23 in my calculator. And that gives me BC equals 15.6. All right, so we know that side. And then the third side, well, you have two options. You can set it up just like we did with BC. So we can use some trig. All we have to do is figure out what side we're dealing with. So AC is adjacent to 23. And then we're going to use the hypotenuse. So I can use A and H. That's the ka in the SOHCAHTOA. So that means I'm going to do cosine of 23 is equal to AC divided by 40. Again, I'm trying to solve for AC, so I'm going to multiply both sides by 40. So I'm typing that into my calculator, 40 times cosine of 23, and that gives me 36.8. Now, we could also use Pythagorean Theorem after we found BC, because when I found that 15.6 was BC, then I knew two sides of a right triangle. So you could use those two sides with the Pythagorean Theorem. So if we do that, let's say we did that. So instead of doing this way, this is just another option. You don't have to do it this way. I'm just giving you another option for that. So you could say AC squared, that's A squared plus B squared equals C squared. So I'm going to square the 15.6 and the 40. And then I'm going to subtract that from the 1600. So that's going to give me AC squared is 1356.64. And then I have to take the square root of both sides. So that's going to give me 36.8. So you see we're going to get the same answer as we did over here with doing the cosine. So it's really up to you what you're more comfortable with. But notice I couldn't do Pythagorean Theorem until I had two sides that I knew. Okay? So keep that in mind. Let's do a few more like that. We're solving right triangles. So in this triangle, the missing pieces are angle V, side MD, and the hypotenuse VD. So the easiest one to do is probably angle V, because I just have to subtract 50 from my 90-degree angle. So angle V plus angle D is equal to 90. So I'm just going to fill in my 50 degrees for D and subtract that to get 40. So angle V is simply 40 degrees. Now let's look at MD. MD, let's label this side. MD is right next to 50, so that's the adjacent side. And the side that they gave me was opposite of 50. So that must mean I need to use TOA. So if I use TOA, that means I'm using tangent. So I'm going to do tangent of 50 is equal to 21 over MD. Now remember, the variable is in the denominator, so we need to cross multiply and divide. So that means that I'm going to get MD equals 21 divided by tan of 50. And if you watch that YouTube video getting tricky with it, you would see that they were talking about that as well. So if I put that in my calculator, I get 17.6. So MD is 17.6. Yay. So we just have one more step. That's VD. So VD is this side, which is the hypotenuse. So I still am going to use the opposite side that they gave me, but I'm using the hypotenuse. So that's O and H. That means so. So I'm going to use so, which means I'm using sine of 50 and that's equal to 21 divided by VD. Again, I'm cross multiplying, so VD is going to switch over to the left-hand side, and the sign of 50 is going to move over here where the VD was. It's like they're switching. All right, so if I type that into the calculator, I get VD equals 27.4. All right, so we have solved this right triangle. Now over here, notice we didn't get any angles, so we have to find two angles, angle N and angle P, and then we have to find the hypotenuse, PN. So let's do the PN first, because PN, notice that I have two sides of my right triangle. I can just do Pythagorean Theorem right away. So I'm going to do 11 squared plus 18 squared equals PN squared. Remember, PN is like your C because that's the longest side. So you square both of those, add them together, and then we're going to take the square root, and that gives us that PN is 21.1. So that's pretty easy. That's what we've been doing all along. So for angle P, let's set up a trig equation. So we are given, if we're looking at angle P, we're given the opposite side and the adjacent side. So we're dealing with TOA. So I'm going to set up a tangent equation. So I'm going to say tangent of P. Tangent of P is equal to 18 over 11. And remember, I have to do inverse tangent if I'm trying to find that angle. So inverse tangent of 18 divided by 11, and that gives me 58.6. Excuse me. So now I have that angle P is 58.6. I can just subtract that from 90, and that'll give me angle N. So I'm just going to do 90 minus the 58.6, and that gives me 31.4. Now you could also do another tangent equation if you wanted to for angle N. That's your choice. I personally like to just subtract from 90 because it's easier. One last problem that I wanted to look at is another angle of elevation, angle of depression one. So we're at this music concert and we're sitting halfway up the bleachers, and the angle of depression to the stage is 24 degrees. So you see how they label that. Notice that this angle is in between the horizontal and that diagonal. Now what else is true is that the angle of elevation is the same. So remember, at that Z shape, those are going to be the same degree. So this is 24 degrees down here as well. So we're trying to find how far it is straight from our line of sight down to the stage, so that D distance. So if I'm doing that, let's look at this angle 24. I know that this is 45 feet tall, and that's the opposite side from my angle 24. And then I'm trying to find D, that's my hypotenuse. So I'm dealing with OH, which is so. So let's use sine. We're going to do sine of 24 is equal to 45 divided by D. Again, D is in the denominator, so D is going to switch places with the sine of 24. So I'm going to get 45 divided by sine of 24, and that gives me 110.6. Now, it told me in the directions to round to the nearest foot, so I'm going to round that up to 111 feet. And there you go. We're going to do a lot more problems with trig.